So I'm going to be talking about a lively topic, coping with the Polyglot Enterprise, and probably kick things off by talking about who I am. My name is Mitch. I'm a recovering Joomla founder. Sorry about that. I started a long time ago, actually in the late 80s, as a hardware person at a company out in California, and was involved in the 2CX and 2CI, which are pretty routinely known as the worst two Macs ever made. It was an interesting time to be in the company. There was a lot of chaos, a lot of growth. And I went down the street to this other company. So you could say that I went from the world's most beautiful computers to the world's ugliest computers in one job. And there I was on the prototype teams. There was the Campus and the Hydra. They both went on to become what we know as a Spark nowadays. So more about me and my background. So I've been primarily starting companies and open source projects for more than 2 decades, probably more than I want to confess. I've lived in a bunch of places. I ended up marrying a European, so I've lived overseas a couple times. My open source contributions go back to the Linux 1X kernel. I think I've got some commits I wrote some ALSA drivers for the ALSA sound system back in the day. It contributed to a bunch of different projects. One you'll see up there is Joomla. I'm one of the founders. I'm actually the John Hancock of Joomla. I had to sign the incorporation paperwork for the nonprofit. Also Mongo Master #1 or #2. We don't know for sure because we deleted the email. So I've been around open source for a really long time. I've been around startups for a very long time, both startups in the Seattle area in the 90s and then startups in New York City in the first decade of the 2000s. Now I'm at Capital One. Which is kind of an interesting trade-off. People are saying, why Capital One? And actually, Capital One was born as a big data company before big data was cool. And I'd like to joke that Capital One has been a tech company its whole life. It just didn't know it. Probably about 6 years ago, that was when the realization came, hey, wait a minute, we're not a financial company. We're a tech company that makes financial services and products, right? So Capital One is very, very big on technology. The shirt I'm rocking today is from an open source project that Capital One has, that sponsors and cares for, called Cloud Custodian. It's a very important tool for enterprise. So show of hands, how many people would consider themselves coming from the enterprise sector? Okay, a handful. All right, so this talk is for you. The rest of you, this talk is going to be even better because you get to sit and watch with a detached satisfaction of the pain and suffering of these few people that just stuck up their hands. All right, so to get things started, you know what? Let's go way back to the very beginning, shall we? In the beginning, we had computers. And computers were expensive, and wow, the care and feeding was daily. And these computers would produce a lot of data. So much data that we really didn't know what to do with it. So we decided to solve this problem by upgrading the computers, right? And that was all good and well, but what we discovered was that as each generation of computer came along, the cost from financial cost, the cost in resources and time, loss of productivity while you figure out the bumps in the road as you find your way down that road, was really painful. And so what a lot of us decided to do was specialize on a specific stack of technology and get the most out of that particular tool. And that brought us a lot of productivity gains. And on top of that, it really streamlined our efforts. The care and feeding was reduced to just daily. And networking was a big advantage as well. Because it was a super upgrade over the previous version of networking for the first generation of computers, which had their own way of shuttling data around. And that's basically the birth of what we call the Monolithic Enterprise. This talk is specifically about how this came to be, where we're at today. I'm trying to use this talk in a very visual and entertaining fashion because I know that it's late in the afternoon. The good news is it's the first day of the conference. If I was on the third day of the conference, I'd be like, okay, free tequila for everybody. But it's really important to understand the monolith was great because everybody could basically focus on their one chosen platform and everything was good. But off in the distance, there was this rumbling sound. and that was Al Gore inventing the internet. And that was a game changer, right? Particularly the World Wide Web was a thing. But that brought some problems with it, because we had trouble scaling these monoliths, right? Our big fancy machines didn't like this stampede of people with web browsers and the reload button. So we did what we should. We got more tools. And these tools helped us solve some of these scale problems. And then we actually added more tools for doing different things. And in the end, we have what I like to call the Polyglot Enterprise. It used to be a day when you could say I was a Java shop, or we're an Oracle shop, or we're a PeopleSoft shop. And I think pretty much everybody can say at this point, nobody can say that anymore. And I don't think even the smaller startups are saying that, because even the smaller startups are using a wide variety of tools. As the image suggests, we basically have toys and more toys, right? We have so many tools. We even have tools that generate more tools. How's that? And then something else happened. It was a game changer. Bet you can guess what I'm referencing with this image. And when the cloud happened, you jumped on the cloud with earnest, just like I did, just like everybody else. And in the beginning, it looked pretty good for you, right? But after a while, things started to change. And we had to solve this problem, because now this was a similar problem that we had in previous generations of computing, but it had the pain infinitely scaled, right? So we created more tools. We created tools for deploying, tools for automating, tools for scanning, tools for packing, tools for compacting, shipping, cleansing, you name it. And that led to some other tools. I bet everybody else here can guess what this slide's referencing. And with containers, well, that was a game changer too. Formerly known as Chroot Jail. No, I'm just kidding. Containers basically made it possible for companies to shuttle around their apps like an artifact. And it didn't matter where that app was being run, as long as it understood what to do with the container image, right? And that made things better. But then that generated another problem for us. And the problem there is, if we tie all of our tooling around a particular vendor, then we're locked in on that specific vendor, which is really no better than the mainframe times, right? Now you're stuck with one vendor. And so a lot of groups would adopt tools like Kubernetes, for instance, and orchestrate the deployment of their infrastructure, their apps. But then they would front everything with an ELB, right? Which didn't make sense to me. I've always thought that was kind of silly, because why would you go through all of this effort to abstract away the instrumentation and the automation of your platforms just to slap a vendor-specific tool in front of it? And that's why, specifically for this talk, I wanted to talk about Nginx. Some interesting things about Nginx. My first experience using Nginx was at a startup in New York. It was a private sale site for moms with small kids. It's a very tough crowd. 4 to 6 million of them. And they would log in every night, promptly at 10 p.m. Eastern, and they would go to the reload button, and they would hammer the site until it was down, because they wanted to see what was going on sale at 10 o'clock, right? And I had here's the funny part. You saw on the About Me slide the word Space Monkey. And that's a nickname I've earned 3 different times in 3 different lives from 3 completely disconnected groups. And the hint behind that is I have a habit of grabbing stuff that's not ready for prime time and then just living the dream. And somehow I've just been incredibly lucky. I'd like to call myself smart, but the proper word is lucky. And in this instance, that was absolutely the case. I had been using, this was what was intended to be a LAMP stack, which morphed into a PHP front end with Mongo backend. And oddly enough, this was the first production e-commerce website that relied solely on MongoDB for all of its data. We were storing everything in Mongo, from not just data and documents, but session data, product images, you name it. And when we went live, we had 2 quad-core servers that were running Lighty and FastCGI to PHP. And then I had 2 quad-core machines that were running Mongo in the background. And when we went live, I was, of course, terrified of what was going to happen with the Mongo servers because I'd never run Mongo at scale, and it was my sole data source, right? Funny enough, when we went live with the site, I logged into DB1 and DB2, and there was no load. And the funny thing is that I'd found this perfect storm for Mongo, because Mongo basically uses a working memory set concept, right? So the first person that come to the website that would look at a listing of the sales, that's a single query over one collection or one table, and it would return 4 or 5 records. That's not hard for a database server, is it? And then someone would click on one of those sales to look at the event, and you're now querying another collection or table, and you're grabbing 30, 45 documents or records, right? So again, very low low workload for the database box. I then went over to Web 1 and Web 2 to see how they were doing, and they had a lot of CPU usage and a lot of memory usage. And I thought, okay, this is my area of scale. This is where I need to take it to 11. So I splurged and went and got some 16-core machines with, 24 gigs of RAM in them. This was big time back then. And I fired everything up on the PHP side of the stack there, and it immediately collapsed. And then I went into a forensic mode and started digging around, and I discovered that Leidy, as soon as this machine had started getting requests, Leidy was seg faulting and doing all kinds of crazy memory corruption problems and just thrashing almost immediately. And so in order to solve my problem, I thought, okay, I need to take a look at what my alternatives are. And at the time, I found this web server. I think I tried to call it Nginx. I didn't know. All the docs were written in Russian. And I felt like I was the only person in New York City who had heard of it at the time. And I did something that was pretty silly. I switched not only the web's front end, but also the scripting interface. So instead of using fast CGI, I used PHP FPM. When I fired up that server, known as Web 3, and took a look at it from a safe distance because I was waiting for something to blow up, as it always does, I noticed that there was no CPU usage and there was no RAM usage, and suddenly the network was very busy, which told me that I had tons of throughput. I had tons of productivity from this web server. So to this day, I'm not exactly sure what the difference was. Was it Leidy? Was it Nginx? Was it fast CGI? Was it switched to PHP FPM? Or was it a combination of the two? I'm not really sure. But that was my first exposure to Nginx. The reason why I'm bringing up Nginx for this talk is actually another experience I had using a tool from Canonical called Juju. Has anyone here heard of Juju? Yeah, like 2 people. I don't understand it. It's like the Jimi Hendrix of orchestration frameworks. It's way ahead of its time. Juju was created years ago. It was originally Python and was redone in Go. And Juju, basically, you could point it at your say your AWS creds, your token and everything else. And then when you type Juju init, it would basically log in on your Amazon account, fire up a tiny or a micro instance, and then set up shop as like a main controller to keep track of your infrastructure. And at that point, you could say, okay, Juju, give me a WordPress, give me a MySQL, and then connect MySQL to WordPress. And this sounds all basic, and that's how Juju wanted to present it to you. And it was great, but it was also cursed because no one understood the crazy neat things that Juju was doing under the hood. One of the things that Juju was doing was it would fire up an EC2 instance, drop Nginx and PHP FPM and a copy of WordPress on it. It would then fire up another EC2 instance with MySQL on it. And then when you said connect MySQL to WordPress, Juju would actually run over to the MySQL box, create a database with a user and a password specific to that database, shuttle that information over to the WordPress instance, update the WordPress config with that username, password, host, and database name. And boom, you're off. You're looking at the WordPress installer. Now, what made this significant was 2 different things. One was it was actually going out and explicitly creating user and password and a database specifically for this app. So actually, Juju's default for setting up WordPress is probably more secure than everybody else's by a long margin, right? By a large margin, sorry. So I thought that was pretty impressive. The second thing was that Juju was not just firing up Nginx on the same instance pointing at the same web front end. It was actually firing up multiple Nginx instances and using Nginx configs to smartly set up load balancing across the bunch. So what that was doing for you was, sure, you were setting yourself up a WordPress blog, but what you're also doing was you were dropping the infrastructure there so that you could grab a visual slider and pull it over when you need more horsepower, you need more databases, or you needed more PHP worker nodes. So it did stuff that pretty much nobody else was doing at the time. This was a very long time ago. This was in the late 2000s, maybe 2009, maybe 2010. I could be wrong. By 2011, I felt like everyone should have been using it and nobody had heard of it, so I thought that was kind of weird. Anyway, so on to modern problems. So one of the best ways that you can solve part of your risks of being tied into a particular vendor is by adding Nginx containers to your Kubernetes infrastructure, so your orchestration has HTTP and HTTPS in front. Why I recommend that is because a lot of companies I've talked to have skipped that and they just rely on ELBs because that's the easy way to do it, right? And then when they want to move their infrastructure over to Google Cloud or Azure, they find out, oh, wait a minute, oh yeah, what's an ELB at Google? What am I going to do? What's the analog? So having that part of your stack from the very beginning is a huge benefit. One other task that I'm going to bring up that's not necessarily Nginx specific, but also is a huge helper. Something I've brought up with a couple people that I've talked to since I've been here. So I'm going to hijack this talk for a few minutes to talk about this. There's a concept called event sourcing. And that's instead of, okay, everyone here has heard about the mad dash for microservices, right? Everybody wants to have a REST service. The problem with a lot of these RESTful services is they're all pretty much what I call cruddy REST services, right? The endpoints for the APIs that you generate with most of these frameworks, I'm looking at you, Ruby on Rails and Node, is typically, hostname / controller / verb / ID, for example. So you might go to mywebsite.com /users / view / 12. That's a common way of building these RESTful endpoints. The problem is you're ferreting away your data underneath that API. So nobody else can access that data without hitting it through your API. That's one of the promises of microservices, right? The drawback of that is you're segregating your data. You took in the monolith and you're just making a whole bunch of tinier monoliths. The second issue is with these endpoints, what you've done is you've polluted your namespace with a bunch of routing tables, right? If you're a large company and you're building a service that's going to have 300 controllers, how are you going to generate all of this documentation using Swagger? Has anyone tried to generate docs for 300 controllers using Swagger? Right? That's click the generate button, go chop down a tree, make a log cabin, come back, see if it's done. So one of the promises of going with event sourcing is that you can separate all of your API calls with two approaches. One approach is to pull your data out of a relational database or a document database and put it at top as an event stream, meaning instead of storing a document, say you might have a document called Mitch, and Mitch wants to change his email, his e-word. That's email and password is one field, I suppose. Concat e-word. So I want to change my email. I do that, and at that point when you look in the database, you no longer know what my previous email was. You just know the current version of Mitch has this email address, right? If you go with an event sourcing model, what happens is instead of storing what Mitch is, you're storing the event. Mitch just changed his email address. Mitch just updated his password. Mitch now has a new friend, or whatever your app is doing. And then your local copy of the data that powers your microservice can keep its stateful copy of Mitch with the current email, current password, and so on, and doesn't have to worry about it. Interesting things happen when you go down that path. One is a lot of the tooling that you end up building to bridge the divide of all of these different microservices is no longer necessary because your source of truth is the stream. Does that make sense? So that's issue number one. Issue number two is now you're storing your data as events as they come in, and then you're processing them out of band. So when you do that, you're now decoupling your front end, your user experience, from all these processes in the back end. And the easiest way to describe this is when you talk to mobile developers, they're like, this doesn't make any sense at all. And you can just smile and say, that's okay. Just understand you don't have to make spinners anymore. And usually a mobile developer in particular will say, I don't have to make spinners anymore. because they hate it, because they go to school, they spend hours and hours and hours learning how to draw and animate stuff. Yay, another beach ball. I'm going to spend 3 days building a beach ball, right? So the decoupling of your apps from their state, simplifying how the data is coming in. For example, I've been using Kafka a lot for this type of stuff. If you set up Kafka as your event stream source, well, Kafka is doing nothing but accepting data and spooling it, right? So there's no bottleneck there. It's going as fast as you can throw data at it. It's not doing a bunch of processing. It's not doing a bunch of thinking. It's just taking your data and spooling. So at that point, you can build background processes that rip through your data and build separate sources of data formatted specifically for each app. Another thing that's a benefit of this, which I brought up earlier today, is that in the enterprise, what happens is you'll have a bunch of data living in a bunch of different systems because you're using this tool from this vendor and that tool from that vendor. And you have a sort of impedance mismatch of your data because this data is keyed on email address and this data is keyed on an employee ID and this data over here is a totally separate identifier that people can change and make just arbitrarily cool nicknames, and that's how they identify themselves for that app. You want to match data across these three services. You got to do a lot of processing. You have to do a lot of thinking, a lot of matching and joining and cleaning up. And that means that if there's 5 teams in your enterprise that are all building 5 different microservices that process this data and do something kind of sort of the same but slightly different, that's why there's 5 teams building 5 apps. One app might be for reporting, one might be for compliance checking, one might be for something else. So there's usually justification for why you have multiple teams building something that's similar but not quite the same. Because they're all forced to pull data from all these different sources, it means that team A might discover, oh, wait a minute, when an account for a person is created over here, it doesn't always have this piece of information. So if I try to match it with a system, sometimes it's going to fail. Maybe team B doesn't figure that out at all and doesn't know that this middle system, you can just arbitrarily change your user ID or your username to something cool like a nickname and call yourself Space Monkey instead of MPT975226 or something like that. So now you've taken your data, you have multiple sources of truth, and that unfortunately has to be because you have these different apps that don't know about each other, they don't talk to each other. But then you're also building your own internal apps, and they're building new sources of truth, and they're not sharing it with each other, and they're not consistent. If you do that formatting up in the stream as a stream processor, for instance, then what happens is a couple things. Subliminally, your engineering teams will stop and say, wait a minute, if I got to pull this data out of the stream, I just discovered that this data may not match because of this one property not getting set, right? If they look and see in the stream that this problem has been solved or it hasn't, and they submit a pull request and say, here you go, I just fixed the problem, then everybody that wants to use that data is now consistent because they're all using the same source data. The other benefit is because it's been formatted there up in the stream, when you pull that data down into your app, you can just use a read-only copy for just local editing, local display, right? The important thing there, when you go that route, is that whenever someone interacts with that data, they may want to change something, or you might have like social curation of results. People can thumb up, thumb down stuff, or star something. You want to push that data back up into the stream as well, or you've just created another source of truth, right? So event sourcing data really is about pushing all of your individual sources of truth into one consistent place where all of your rules and formatting and problem solving and fixing can happen once and be done. I'm going to try something different with this talk. I went through this talk a little quick. A lot of the information that I wanted to cover was already covered by my good friends at Nginx because they know the pain that I'm feeling, and my handful of colleagues who stuck their arms up and said, yeah, I'm in an enterprise. Well, they know what we're all feeling, and so they're putting together products to solve these problems. So the funny part is that a lot of my fire was spoken about at 9:30 this morning. So my thinking is to open this up to a Q&A format and talk more about more broad questions about dealing with either orchestration automation, dealing with shuttling data around, because I don't know about, I can't speak for anybody else, but I myself, one of my biggest problems, sources of pain is data. For the last 10, 15 years, it's been all about the app. right? The 90s was all about the operating system. It was all about Linux, right? 2000s hit, and then it was all about the app. It was Ruby, Ruby on Rails, Python, Zope and Plone, PHP with Joomla and Drupal and WordPress, and then Node came, and now we've got microservices just adding to the pain and suffering. But nobody's really done a whole lot about solving data problems, and having a lot of data on a bunch of virtualized systems is a hassle to deal with. When you have petabytes of data and you're in a hurry and you're out on the cloud, you're in a bad place, right? I think everybody heard about the Foursquare outage from a couple years ago. Part of that was because instead of going with like a Borg route of having 1 million smaller instances, they had a handful of really big instances, right? So I forget what node it was. Node 6 goes down. Well, node 6 took like a terabyte of data with it when it bit the dust. So the cost of recovering that data and getting that system concurrent with the rest of the systems in that cluster was a major source of pain for them. It cost them days. I've seen a key value project with a very unfortunate name of Project Voldemort. Anyway, but wait, it gets better. They created something that I thought was genius. They thought, okay, imagine if you have 10 nodes in a cluster. Instead of when node 4 goes down, normally what happens is it's going to pull 3 and 5 with it, right? Because when 4 goes down, suddenly 3 and 5 have 50% extra load to handle. And they're like, oh, tengo dinero, and drop. So what this team came up with was a concept of spreading that workload in incremental pieces around the entire cluster. So instead of making like a horizontal cluster, they made a circular cluster. Unfortunately, just like the project name, they came up with this beautiful name. They called it a hash ring. So it was like he who should not be named bringing over, I don't know, a pot from Afghanistan or something. I don't know. The names were terrible, but the concept was great. The architecture was a great idea. I wished more data projects would have followed that architecture because that pattern was very elegant. So when node number 4 goes down, all the other nodes are picking up a percentage of what node 4 was doing as opposed to the ones before and after just getting hammered and pretty much dying on the spot. So I want to open up for Q&A. If there's anybody here that's interested or has questions or observations too. For me, it's more about bringing up getting a discussion about some of these challenges, some of these issues. Thank you.
So in the enterprise, especially in financial services, you've got a super tanker of existing code and data practices, right? So today everyone's going west. And so if you could turn that super tanker west, but maybe by the time you do that, everybody's going east. So how do you adopt new technologies in that kind of environment that's going to last longer than any one technology?
All right, so to repeat the question, since we're also filming, so the question was, for example, in the financial sector, it's like a super tanker, and you may want to make a hard turn and go west. Everybody else is going east. How do you decide? So the question is basically, how do you introduce technological change in an environment where these systems are going to be around when the rest of us are long gone, right? Yeah, that's a very valid problem, especially in finance, because what happened in finance was there were a handful of vendors who basically dominated the landscape. And the funny part is I had to live through this before in the telcos. Was it 30 years ago? My gosh, it was 30 years ago. I'm sorry, I'm old. 30 years ago, I found myself working for this company called US West. And I was working in this super modern language called Perl. And yeah, that's how long ago this was. And the problem was that all of the phone companies, the Baby Bells, or RBOX as they were called, regional bell operating system companies, all of the RBOX were running on the same, in some instances, the same physical mainframe. But they were required by law to not be a monopoly. So this group got to live on these processors and disks and memory boards, and this phone company got to live over here on this set of CPUs and disks. And it was a very unnatural dance. A lot of companies in finance right now are doing a couple of things to introduce technological change very quickly. I'm very proud in how Capital One has responded. Capital One's been like the first finance company to really go all in on public cloud infrastructure. So they're extremely aggressive about that. Actually, I've already talked about this shirt a couple times today, so I don't know if I've mentioned that here on stage. I'm pimping an open source shirt from Capital One. The project is called Cloud Custodian, and Cloud Custodian was written out of the need of keeping track of this college dorm room of virtualized apps running on AWS. Because when you plug in 8,000 developers, 6,000 developers to AWS, all kinds of madness and mayhem is going to follow. And so this tool was written specifically to audit and keep track of all the instances that are out there. Now, you may have instances that need to be rehydrated. You might have a policy. I don't know if anybody here is familiar with that. The concept is, even in a virtualized environment, if the operating system is more than, say, 60 or 90 days old, I want to restart a newer instance of that same base image just so I know I've got the latest patches and so on. And the common term is rehydration. So one thing that Cloud Custodian does is it respects your your rehydration strategy. Another thing it does is it looks to see if all your instances are properly tagged, for instance. And the last one, which I think is actually kind of cool, is it'll look and say, have you been tagged with "Don't kill me, please"? Yes? All right. I'm just going to turn you off. It's 7 o'clock. Nobody's using you right now. I'll turn you back on in the morning. And so we're automating shutdown of all these instances. We're not terminating. We're just shutting them down and then starting them up again in the morning. It's a massive savings on virtualization, right? And I've actually never seen anyone in the financial sector come up with that idea. Last time I saw that was actually at a startup in New York that I was working with called Gilt. And Gilt had the same idea. If we virtualize, because every morning Gilt was firing up, literally, Gilt would fire up like 300 nodes. They were using Joyent at the time, if I remember. And they would fire up like 300 nodes on Joyent, which back then was insane. And they would run them for like 2 hours. And then they would turn them off because they weren't needed anymore, because their private sales would only run half an hour and all the products are gone. They had millions of people using their site. So for them, virtualization was a godsend, right? Because they could just fire up all this computing power, use it, and then turn it off. Capital One basically said, we're going to do the same, but we're going to tie it to office hours. So if the last person leaves the San Francisco office at this time, I'm turning everything off. If you need to, you can tag it with a special tag that says, Cloud Custodian, don't kill me, or something silly like that. And when Custodian sees that instance, it'll say, okay, I'm going to leave you because you're persistent. You can't be terminated or shut down because you need to run jobs or process data that's being dropped off or whatnot. That one thing about that is that I think Capital One did really well is its adoption of public cloud infrastructure. Another thing is, it's hard to answer this one right. I'm trying to find the right words. I think Capital One did something that's also really unique. When they had this epiphany and said, oh, we're a tech company, we're not a financial company. They didn't say, okay, we're a tech company and we're building everything in Java and we're going to use this tool to deploy it, we're going to use that tool to scan it. They never did that whole, one ring to rule them all kind of deal. And I think that it produced some really cool side effects. Yes, there's duplication, right? But the flip side is that you have teams that understand a certain tool set and they've been empowered to leverage that to the hilt to be as productive as they can. And so one of the things that I think the enterprise space can do better is that when you do stuff like that to empower teams, allow them to adopt new technologies, Go is really on fire right now. I know a lot of people inside of, and not just Capital One, but other companies in the enterprise space are really falling in love with Go, and for good reason. I think it's a really good fit. The tooling that goes around it needs to be brought up to shape too. So you might have a corporate system that scans source code to look for common vulnerabilities or licenses in use for libraries and whatnot. And a lot of that tooling doesn't know what Go is yet, right? So when you adopt these new tools, you have to be careful about fitting that into your existing pipeline of goodies. That's one thing that I've seen frustrate adoption of emerging technologies, at least in the enterprise space, not just with Capital One. Let's see, other good tricks for getting change. One of the things that I think has really had untold benefits is, I talked about event sourcing, but one thing that is an interesting side effect of that, and I talked a little bit about it, is that when you push all your data up into a stream, and then everybody has to consume data coming out of that stream, it makes your engineers way more deliberate about what they're building from a data perspective. Because I don't know about the rest of you, but when I was Mitch, the startup CTO, data was data, man. I was just trying to build the apps, right? So the data was as simple as possible just so I could get the job done. When I'm looking at data that I know is going to be reused by maybe thousands, then I'm way more explicit about what I'm building, what I'm designing, what kind of names am I using for these properties, why am I storing this data, qualifying what I'm putting into this data stream. Is this going to be useful or is this just noise? And what also happens is that you'll have engineering teams that don't talk to each other very frequently. Will say, I need to talk to these people because I know they're the ones that worked on the last version of this particular topic in the data stream. I want to talk to them about why this wasn't included. Do they know that it wasn't there and needed to be there? Or maybe they know something I don't. And suddenly your engineering teams start talking with each other. So it's kind of a fun side effect of that process is now you've got engineers talking to each other from different groups and they start to share information, share war stories and figure out, hey, I think I got a shortcut that everybody can use. It's a good question. Good question. Any other questions? Yes.
The last speaker was talking about microservices, uniforms, microservices. And one of the key points I think is that some of the companies, especially enterprise companies, may not be hiring the right staff or not sure how to build staff into people who can work on that type of code. So do you have any techniques that you can share of how you maybe brought new people up to speed, or the techniques that you use for recruiting people that you think would be able to work on microservices in an enterprise application?
Okay, so a couple of things that we do that I think are really cool. Yes, repeat the question. Sorry. So the question is, a lot of these companies are being told to go out there and microservices, and they may not be sourcing the right people to be hiring as engineers to be building microservices, or they might be bringing in a bunch of new hires to solve that problem and not knowing whether they have the skills or the training necessary to do it and do it right. And doing it right is far less common than, unfortunately, I'm seeing. What we do, which I think is a really cool approach, is, and I've never seen a company this size do such a great job of onboarding talent. There are multiple programs inside the company that basically will take new hires, in a sense fresh out of college, and put them through a training boot camp. And in the end, have like a sorting hat type of moment where you're mobile, your back end, your front end, your orchestration and DevOps, that kind of stuff. And that whole process will help find that kind of mentality and try to promote that best practice. I think something else that we do, actually why my group exists in the first place. I'm part of the Tech Fellows program. The Tech Fellows program was founded inside of Capital One to basically bring in like senior level individual contributors to walk the walk, right? To cause as much trouble and mischief as possible. I've been running around the tarmac with great glee for the better part of 2 years in this role. But part of that role is also being able to surface, here's how microservices should be done, and the responsibility as a public speaker is to be able to proliferate those ideas, to teach and show everybody else how to fish. So I think that's probably just as important, is making sure that anybody who is in the process of building those types of apps understands there's the right way to do it and then the way everybody's going to show you how to do it. Or at least that's my take on microservices. There was another question over here. There.
You talked about the event stream being the source of truth for the data. Where does that live and what form does that take?
Okay, so the example I used was Kafka, right? The question, sorry. I was talking about the event stream earlier, and the question is, you mentioned the event stream as a source of truth. What does that data look like, and how does it live there? Kafka basically streams data as text. So the best part about Kafka in that regard is that you can actually spool your data straight to an S3 bucket, for instance. And then if it's more data than you can handle in a particular cluster, then you can just spool the excess data into a bucket. If someone comes by later and says, I need to rip through this data to process it to come up with some other subset of data for a different app, or you need to look farther back in the future than the existing system can handle, you can literally spool that through a current version of Kafka, grab the data that you need, and then terminate those instances. And you're not losing any data because it's just spooled and sitting in a bucket, right? The fact that Kafka is ripping through text means that you're not going to lose huge performance because it's doing something extremely simple, right? So it's first in, first out, very fast. It's just streaming text data. I think there's probably time for one more question, and then I'm done. Is there another question here? All right. I'm sorry, any issues like? Okay, the question was on AWS, are you hitting rate limits? The joke is, as a developer, I'm like, I hope we have another reorg and I get a different AWS account. We have AWS accounts that are so busy that I'm telling you, the API limits, you can't even see if your instance is running at this point. You're literally forced to ping an IP address. So anyway, yeah, absolutely. I think that, and again, I think that it's important. Being able to use infrastructure that is not vendor specific will help you bypass a lot of those issues. If you have to build multiple accounts, you can. If you have to spread your accounts across multiple providers, you can. That's by far the best approach as far as I've seen. It's an open source project. Pull requests are welcome. It is. It's on public GitHub. All right. Well, thank you very much.